Quick, tell me what an atom looks like. Now that our Dora the Explorer moment is over, you probably said, well, something like a sphere, duh. Whenever most people picture an atom, they think of a sphere. This is pretty much true. The electron cloud whizzing around the nucleus will oftentimes form a roughly spherical cloud. Any sphere, and therefore any atom, has a radius. We call this the atomic radius, and it is basically the distance from the center of the atom to the outermost bit of its electron cloud. Now, this is a very, very small distance, but across all of the elements on the periodic table, the length of the atomic radius does follow a trend. Now, keep in mind that the radius of a single atom cannot be directly measured. To find the atomic radius of an element, we must look at two atoms of this element when they are as close together as possible. The distance between the two centers of these atoms is called the internuclear distance, and from this diagram you can see that it is not far off from the diameter of just one of these atoms. Now, because we know radius is 1/2 of the diameter, we calculate the atomic radius by dividing the internuclear distance by 2. Now, the trend of atomic radius is that it increases going down a column on the periodic table and decreases going across a row. The explanation for this is a little tricky and requires knowledge of electron configurations, which we have not yet covered. Electrons occupy distinct energy levels outside of the nucleus, with each new energy level being farther from the nucleus. A new energy level appears every time we move down a row on the table. For instance, the first row containing hydrogen and helium contains only principal energy level 1. The next row, starting with lithium, contains principal energy level 2, which is farther out than principal energy level 1. Because of this, there exists a greater radius in lithium than in hydrogen. This is why going down a column on the periodic table increases the atomic radius. Now, why does it decrease when we go across a row? In a row, the principal energy level is the same. That is, the distance from the nucleus to the outermost electrons does not increase. It can, however, decrease. Remember how positive and negative charges attract, just as positive and negative poles of a magnet do? The same applies here. Going across a row, the number of positive protons increases, and so do the number of negative electrons. Because of this, there's a greater attractive force going across a row on the periodic table. Thus, as you go across a row, the electrons are being pulled tighter to the nucleus of the atom where the protons are, and therefore the atomic radius shrinks. As a recap, there are only two kinds of trends as it comes to atomic properties. Trend 1 is increasing down while decreasing across, and trend 2 is decreasing down while increasing across. Atomic radius follows trend 1.